In this video we'll look at two ways in which we can work out the distance travelled by a particle travelling in a straight line. We're given the velocity formula here, and we can factorise that. We end up with a linear and a quadratic. The quadratic can be factorised. So we end up with a sign diagram that shows us at t equals 0, 2 and 4 we have the particle stopping and changing direction. Now, to work out the distance travelled, we'd need to integrate velocity in order to get our displacement function, which is what we have here. And now we can work out the displacement at t0, t equals 2 and t equals 4, which I've calculated already. So when t equals 0 we get c, when t equals 2 we get 4, and we get c again at s4. And if we draw a motion diagram, we can then work out the distance travelled, and a motion diagram would look somewhat like this. And we have the particle starting at c. From our motion diagram, we are travelling to the right for the first 2 seconds, so we travel across to here, then we turn around again and we end up where we started. So the distance travelled therefore will be 4 plus 4 units. So from here to here is 4 units and back again. So 8 units is the distance travelled. So that's doing it using algebra. Let's do it now using the calculator. So I've entered in the equation for velocity, and if we were to draw that equation, we end up with our cubic there. Now we know that the area under the curve should in fact give us the displacement, but if I want the distance travelled, then I'd want that area plus that area there. Now if I were to work out the definite integral, this would be a negative, this would be a positive, and we won't end up with what we want. So what we can do is draw the absolute function. So that's the modulus of my velocity. So if I go for option, number, then ABS, there's my absolute function, and I want y1. So I can press F1 for the y, and then 1. And if I draw both, there's the original graph, and you can see that overlaid is the modulus. Let me go back and I shall deselect the original function and just draw the modulus function. So now I want to work out this area here plus that area there. So now if I go for G-solve, then go across and hit the definite integral, my lower value would be 0 at time 0, that's when we started. And for the first 4 seconds I would stop at upper value of 4, and we can see it shades it in, and we get our value down here of 8.